Hello everyone, and welcome to our closeout video for the zkey-fold UPLC converter project. We entered the Cardano Open Developers track of the Cardano Project Catalyst Fund 12, since our UPLC converter improves Cardano's tooling by enabling any Cardano developer to create a zk smart contract from an existing untyped Bluetooth core script. Once our project went live, we progressed slowly but steady, closing several critical technical milestones. Along the way, we had to come up with an architecture for converting an untyped language, UPLC, into simply typed one, our zkey-fold symbolic. The most interesting parts were setting up a type-driven way to convert built-in functions of UPLC into its symbolic counterparts, and designing a type of variable length byte strings, which is compatible with fixed-length arithmetic circuits. We managed to keep the project in scope, setting out the following milestones and KPIs. A functional UPLC to ZK circuit conversion, support for basic and complex built-in operations, CLI tool for developer usability, documentation and developer onboarding, test coverage and reliability, integration readiness with other language toolchains, and last but not least, modularity and extensibility of architecture. We achieved all of them. The fun challenges then were the following. Create documentation. Then, implement a prototype for a limited subset of UPLC. After that, circuit generation for basic built-in operations. In addition, circuit generation for more complex built-in operations. And last but not least, CLI tool prototype with the core functionality. Once again, we achieved all of them. You can find the details in our closeout report, which I'm showing you right now. To actually use our UPLC converter to transpile UPLC code to zero-knowledge circuits, you just need to run the converter CLI, which is called zkey-fold UPLC converter, which can be found in our zkey-fold Cardano repo. For example, here's a simple UPLC script we prepared in advance. First, it performs a redundant equality check on integers, and then it checks that the input UPLC data is a byte string and is equal to 1234 dead foot. A corresponding arithmetic circuit is obtained by actually running the CLI on an example file. It's going to take a while, since the circuit is huge. Well, byte string can be of arbitrary size, remember? But nevertheless, it will produce the output we want in a JSON format. Let's wait a bit. Yeah, so here it is. It contains some information about how to compute the witnesses and, well, the constraints of the arithmetic circuit itself. We still need to polish our converter a bit. We need to add more tests, integrate it tighter with existing UPLC tooling. Well, however, we do not seek further funding for this, and now that we have a working prototype, we would like to use it in the future for easier conversion of real existing Cardano smart contracts into arithmetic circuits. This would be used for an easy jumpstart into using our own Layer 2 blockchain, which uses arithmetic circuits as a smart contract language. And well, that's it. That was our closeout video for zkey-fold UPLC converter. See you soon. See you next time.